That's what we want. All right. Good morning, everyone. Mark Seibert here. I'm part of the nutrient management team with the Division of Soil and Water Conservation. Um, and I'm here to give you a basic overview of the nutrient management in North Carolina. So, Dalton ended with a map. I'm going to start with one. These are the folks that are involved with the nutrient management team. Looking at the counties that you represent, I think the majority of you are in Michael Shepard's region. Some of you, maybe one or two that are in the eastern area are in Sam's. And I am not going to probably involve too directly with most of you because I generally do most of my work in the four counties because my role is a little bit different than the other folks. And we'll talk about that in just a moment. Let's see. All right. So, to folks, these are the contacts for each of us. Of course, they're available in a variety of different places to you. Some of the things that you would reach out to our team to get involved with are to work on some waste utilization plans, writing them, revising them for your cooperators. Anything related to lagoon, the technical stuff on lagoons like markers, doing sludge surveys, waste samples, testing, that type of thing. And we do get involved with any kind of plans of actions that might be required for the permitted operations. So I got a quick little video here for you of a sonar boat doing a sludge survey. That's probably enough of that. Uh, but the gist of that is it's just a tool that we can use as part of our nutrient management planning, particularly for sludge cleanouts or lagoon closure type projects. I think you can use it for other things as well. Some of the counties do a lot of water point work where they're identifying water sources for firefighting, and that tool can be used in that way as well. So here's some of the other things that we get involved with. Operation reviews on farms, wettable acreage determinations, which essentially outline areas that are permitted for waste application. And then what I get involved with in the four counties that were on identified as my responsibility, I actually do the annual inspections for the permitted operations, the swine operations. Typically in North Carolina, the DEQ, DWR are the folks that do that inspections, but long ago, someone decided that we needed the Department of Ag to do four of them as a comparison, contrast, balance, whatever you want to call it, for the inspections. So that's my primary responsibility, is doing those inspections. Here's an example of a wettable acres map that we produced in conjunction with a sludge application plan. It gives you some idea of what that might look like. In addition to doing actual technical services, our staff is responsible for a few program implementations. Swine and dairy, which is what you hear about a lot with the lagoon closures, is probably one of the biggest responsibilities we have at the moment. Ongoing is technical specialist designation, which is folks that have received nutrient management training and have gone through a application and a review process to get certified, can be technical specialists that are qualified to write waste management plans. And these folks don't have to be with the division. They can be private enterprise, they can be district folks, they can be, well, anyone who meets the criteria, I suppose. But that's one thing that we get involved with as well. I mentioned the inspections, and then one that you will probably cross paths with if you already have it is the nutrient management software. We're responsible for that as well. And if you go to if you search nutrient management software in North Carolina, this is what you're going to find. NC State website is where it's housed, I guess. And you actually, at this point, it's software that's downloaded onto your computer that allows you to import all the information for soil testing and waste testing from the state lab that you would need to develop a plan. And that would be the product that you would get from this would be a waste management plan or a nutrient management plan, depending on your circumstances. And there's an effort on this to make this a web-based application, but that's somewhere in the future, probably multiple years down the road till that happens. So if you're going to get involved with it, this is probably where you'll be. I'm going to kind of check the pulse out there a little bit on these trainings in the chat, if you don't mind. Indicate if any of you have had this training, the operator in charge training. And just like I said, check the pulse here. Give me a yes or a no, if you don't mind. Okay. Well, doing environmental education work doesn't eliminate you from taking this training. It might be a good cross training for you to do. This operator in charge training is the one that people who have permits that they operate under for and handle animal waste are required to take. And if you were interested in expanding your nutrient management knowledge, it'd probably be your first step. So they've got a class coming up in the not too distant future in January. Look into that if you're at all interested. Second on the list for training. Oh, my advance is weird. Let me try it this way. There we go. Okay, second on your list is a full-blown week of training that NC State hosts and that we help present that takes place in Raleigh. That's scheduled for March this coming year. That would, like I said, would kind of be step two, unless you're already have studied nutrient management at some point. That would probably be second on your list to take. It does involve testing at the end with a I'm not going to go into too much detail, but it's a rather challenging test. You have to know your subject pretty well to complete that. And then if you've completed that, third down the line is a more advanced nutrient management training. We're planning on presenting that next July at the Piedmont Research Station, and that's where we anticipate allowing folks to bring the information in for like developing specific plans, the information that they already have in hand and would like to walk through like the actual use of the software and get more detailed with that. Let's see. So now we're going to change gears a little bit. We talked about technical assistance and who does it and what's available to you. And we're going to start at like step one of nutrient management and hopefully proceed from there to some information that can be of direct use to you. So basically, nutrient management is feeding plants. And in most of the cases we're going to get involved with, a plant that's being produced for some sort of a agricultural commodity. So a healthy plant versus a nutrient deficient plant is apparent, obviously, and starts with the soil. Dalton talked about all the soil properties that are important for building structures, important for supporting practices that you may implement. Nutrient management also starts with the soil. The soil is the reservoir where the nutrients that plants utilize to grow are housed. So that's where it all begins. You may have seen this diagram somewhere in your trainings, but the soil is made up of the mineral portion, which many people think about, but probably not just as important. other important factors include water, air, and organic matter, and they're critical to the function of the soil and how suitable they are for growing good crops, growing good trees, whatever the case might be. A tie back to the soil and water conservation districts is that soil erosion prevention is key to reducing nutrient management loss from agricultural land. Essentially, that's the equation is that simple. You lose soil, you lose nutrients. So it's in everybody's benefit to prevent soil erosion. Will this be posted? My understanding is that it's being recorded and would be able to be viewed at a later time. Is that right, Dalton?
I think that's correct. I got from Brandy. She was going to cut it and send this out later.
Yeah, Brandy would know the details on how to access it, and I'm sure she can pass that along. We'll ask her to, actually. So have a good field visit. Thanks. So super simple soil loss fundamentals. If you have the soil covered with vegetation or crop residue, you're going to have lower soil loss than bare soil. If you have perennial vegetation, you're going to have minimal soil loss. So a real quick thing for you guys. This is going to take like 10 seconds, hopefully. Rank these. Just give me the numbers in your chat. Rank these erosion risks from highest to lowest. Give me the number there. So the scenarios are grazed pasture, corn, grain, conventional tillage, soybeans, no tillage, and pine forest. So there's distinct differences there between those different land management activities, and probably distinct differences in their susceptibility to erosion. So let's see some numbers. Give you 30 seconds to type. Okay, we got some good responses there. 2, I would agree, is probably the highest risk for soil erosion. The next likely would be soybeans, no tillage, despite the fact that it's no tillage. Soybeans is somewhat of a low residue crop, and if you were to look at the erodibility factors for these different land uses, that would be second. Pasture would probably be third, and forest would be fourth. So good job. There's a tool. Have you guys have crops do have erodibility factors, and they're built into this tool that I just put on the screen. It's called Revised Universal Soil Loss Equation. That's what Russell stands for. It's a soil loss estimation tool that was developed by USDA NRCS. It's built into a lot of the conservation practices. You need to use this tool to estimate your erosion and your soil loss. It's built into the nutrient management software. You need to use Russell as a part of assessing risk for nutrient management practices as well. So yeah, so every scenario that you can imagine, a rotation of corn, wheat, soybeans, anything, even much more obscure than that, there is a factor assigned, for lack of a better word. I'm struggling for the word that really suits it. But yes, in the soil loss equation, you do use erodibility factors for different crops. And there's actually different erodibility factors for different soils. And that's what all these acronyms. And I guess another plug would be when there is Russell 2 training provided periodically that's available for district folks to attend. So look for that as well if you get the opportunity. Okay, so why do we as soil and water conservation folks, district folks, division folks, plan nutrient management based on nitrogen and phosphorus? Why do we lean so hard on them? It's because of water quality. Nitrogen has big effects on water quality. Same for phosphorus. Big effect from over application and loss of phosphorus from agricultural lands on water quality. You probably at some point in your training have seen something that looks similar to this. I'll back up. I stole most of this off of the internet, but this one in particular, this shows you nitrogen and phosphorus pathways for losses. We mentioned that nutrients are held in the soil. That's certainly true for both of these. And then these are the type of pathways that you would typically lose them from the field. And I think the arrows are intended to kind of represent the extent as well. You see nitrogen is more susceptible to leaching through the soil into groundwater as an example than phosphorus would be. So just a little reminder of that kind of a principle. So what we get involved with our assistants a lot is, as I said, developing waste management plans for animal manures. But in North Carolina, in agricultural land, you've got two primary nutrient sources that you're dealing with, either fertilizers, dry or liquid forms primarily, and then animal manures. Where is that manure coming from? It's coming from livestock farms. North Carolina has a large, varied livestock industry. These are large numbers, 4,600 poultry farms in North Carolina. I had to double check to make sure I had the right number of zeros here. That says greater than 1 billion birds produced annually. Here, as I mentioned earlier, what I deal with primarily are swine farms. And in North Carolina, there's 2,400 permitted swine farms, and their production amounts to about 17 million hogs produced per year. In addition to those, we have about 120 dairy farms with 38,000 cows, and beef cattle, 350,000 cattle statewide. I was a little surprised that number was that high, but this is what USDA reports as in the Census of Agriculture. So where are they? This is going to have some effect on your involvement and your work related to waste management, nutrient management. There are areas of the state that are much more heavily concentrated with livestock than others, and this is just to illustrate that point. This shows all swine and poultry. You don't really have to worry about the colors. Those just have to do with when they were built. This also concentration of the swine, in particular in the orange dots. The blue dots represent the permitted dairies that are in the state of North Carolina. Feel free to hit me with questions as we go along. I want to make sure you're still there as we go. So typical like manure storage utilization for a swine facility like this, a lagoon, or the storage and treatment of the wastes that come out of the barns. The ultimate application and utilization of the nutrients is typically done by wastewater irrigation on swine farms. Another little video. Humor me. So I mentioned a second ago that the primary way we handle the waste from swine is to irrigate the wastewater. That's the water that is present on top of the lagoon. Down below it, sludge accumulates, which is a more solid form of manure. This is a video of sludge agitation taking place on a farm, and then this is application of that sludge to other agricultural land. We mentioned there are a lot of poultry operations. This is what typical poultry litter handling looks like. The poultry manure, generally speaking, on most of the farms is going to be a drier material, a stackable material. It typically goes from the production barn to either a storage shed, like a roof shed, or directly out to fields and piled up for land application by an implement that looks something like that. And then the dairy typically is applied as liquid manure, and most of the beef manure application in North Carolina looks something like that. You'll probably get involved with some storage structures for beef manure as well, where you have concentrated feeding areas and stuff. But in general, a lot of the manure application takes place on the pastures by the animals themselves. Okay, question over here about closures of waste lagoons. Yes, and in fact, our exercise at the end of this is directly related to that. So hang with me, and we'll get more into detail on that. So a nutrient management plan that I mentioned that you can develop with our software, this is what it ends up being. Basically, what's being produced and where is it going, and what measures are being taken to make sure that it's done well. And this is basically the 4 R's of nutrient stewardship. You'll see these different places, different times in presentations. That you want to have the source of manure be the correct one for the time that you apply it, the rate you apply it, and where it goes. And built into all this are best management practices that are used on the land to manage it as well. So here's we're alluding to the timing of nutrient application. Nutrient application, nitrogen, phosphorus, any nutrients you're applying ought to be applied at a time that's most appropriate. And what that means is basically it's most needed by the plants at that time. So each plant has a utilization curve. Each type of plant, I guess you should say, has a utilization curve that relates to when is it using nutrients. And it varies based on the type of plant it is and when its growth takes place. That's just to illustrate the different crops have different timing. And what you'll see come from that is that there are windows of application for manures onto crops based on when they need them. So a lot of the farms that I inspect, well, back up a second here. Bermuda grass is very typical. Rye and Bermuda grass, which would be Bermuda grass in the summertime, utilizing a lot of nutrients, and then rye overseeds in the wintertime, utilizing a lot of nutrients. That's one of the typical systems that I see on inspections for the swine farms, and it's based on this fact that the Bermuda grass utilizes nutrients well through the summer and a lot of nitrogen, and the rye utilizes nutrients, as you see by these bars, over the wintertime. So most of the manure application rates in North Carolina nutrient management or waste management plans are planned for the nitrogen crop needs, and that's the case with swine facilities. They're almost all based on nitrogen application rates, and it's based on plant available nitrogen. That's another term that you need to get familiar with. Phosphorus accumulation is monitored in the soil by soil testing, as well as metals are monitored by soil testing, but the actual plans typically are based on nitrogen. The case is the same with poultry, but the poultry isn't required to have inspections or written plans. They're what's considered deemed permitted in North Carolina, which means there are requirements that they're supposed to meet, but there isn't any inspection or really direct oversight unless there's some kind of a problem. I'm sorry, I'm reading a comment here about lagoons that still exist. I read information. Okay. We'll get into that too a little further down the road if you'll give me a little patience. Has anyone seen a soil test report from the state lab? Just give me a quick yes or no on that one. Okay. Well, this is what they look like. If you take a soil sample on a field, or even a lawn, and you send it to the state lab in Raleigh, they will produce a report at no cost for most of the year. They do have a season in the wintertime when they're the busiest that they do charge, but for most of the year, you can get a free soil test. And what that'll come back, it'll tell you all the important characteristics of the soil that are relevant to growing crops or growing a lawn. And it'll end up ultimately giving you some recommendations for nutrient application based on your soil characteristics. And I mentioned earlier about the nitrogen-based plans being primarily what we see in North Carolina, primarily what's required. This is another term that you would need to get familiar with related to that: realistic yield expectation, RYE. You'll see that everywhere. And what that is it takes into consideration the crop and how well it grows on a particular soil and gives you a nitrogen rate based on that. So let's start with this one. Based on your training, corn nitrogen needs, would you categorize the nitrogen needs as high, medium, or low? If you were to go out here and grow this crop in North Carolina, you were going to fertilize it, you know it needs some nitrogen to grow, how would you characterize it? High needs, medium, low? I'll give you a second. We got Catherine in with a high. Anyone else? There we go. Oh, okay. I guess based on plant height. Okay. All right. Well, it is a big crop. There is a lot of volume of plant there. That's true. All right, I'm going to move along. The way you would answer that question in a technical way is you would go here to the realistic yield expectations for North Carolina soils. It's a website that the university maintains. For the purposes of what we're doing, I'm going to jump past going to the website and give you the results that it's going to pump out. For corn, as I said, this is by soil type. We looked at the web soil survey earlier with Dalton. That'd be your starting point to know what soil type you predominantly had on the field. Then once you had that established, you can use that and your crop to figure out what your nitrogen requirement and your phosphorus requirement for that crop would be. So in this example, we said corn in the photo. This is saying to grow 168 bushels of yield, that we have a nitrogen rate of 131 pounds per acre of nitrogen to apply. The phosphorus that will be removed in the growth of that crop is 74 pounds. How about soybeans? Let's do this again. And you folks that didn't answer the last time, jump in on this. Soybean needs high, medium, low. Give me a quick type. All right, one more answer and we move on. Gonna hold out on you. Dalton, you can be the one. I can't see the other folks there. There we go. We got another vote coming in. Okay. Okay. Well,
Highs and mediums.
okay. Yeah. So from the same source, from that website, we inputted soybeans. And this is a little bit of a trick question, to be honest. because you'll see two different rates. Soybeans double cropped, which means you would be growing them after another crop in the summer, perhaps wheat or barley. Your nitrogen rate, 0. Soybeans, full season, 41 bushels, meaning that's your crop for the entire summer. Nitrogen rate, 0. If you think back to some of your biology in the past, soybeans are a legume. They have the ability to fix nitrogen from the air for their growth. So that's why this N rate is 0 for soybeans. But as I said, it's kind of a trick question because we also have soybeans double cropped manured at 134 pound rate. We have soybeans full season manured at 161 pound rate. Well, that makes no sense. Well, this would be applicable in a scenario where someone has a abundant source of manure that they needed to utilize. And what basically takes place is by applying nitrogen, you, in a sense, override the nitrogen fixation of the legume, and you provide the nitrogen, and it doesn't bother to work to supply it for itself. So it does utilize a lot of nitrogen, either by its own production or by application. So here's one that's relevant to the soil and water districts. Cover crop, nitrogen needs, phosphorus needs. Now, I'll rephrase that a little bit. Let's not say needs, let's say applications. How much nitrogen should you apply on, say, a rye cover crop that you're putting in after a corn crop? We can answer this one. You guys do any cover crop work? Familiar with it? If not, you probably will be as you get more involved with the district activities and the cost share stuff. Jumping ahead, low is correct. Cover crops are by design a scavenger. They're planted for the specific reason to go out there and establish themselves and utilize nutrients that are already there. That's the whole intent of the cost share cover crop program. And as I said, that's probably one that you'll get pretty involved with as time goes on. So if we're attempting to write a waste management plan, most of them, as I said, are either nitrogen based or phosphorus based. What's the main differences? Typically, if you base all your planning on nitrogen needs, you're going to exceed your phosphorus application rate. And this is if you're providing the nutrients with manure, because the ratios are typically not exactly what you're looking for. The other thing, particularly with hog waste and particularly with nursery farms on hogs, is that you're going to over apply zinc, and that can accumulate in the soil. And Dalton could probably knows a lot more about this than I do, but basically zinc is a heavy metal that is going to be a forever residing in the soil, and it can in fact be toxic to some other crops and plants. So that's another thing that's monitored on the farms that are under permitting, and it's something that shows on the soil tests that you may want to take a look at as well. If you switch to phosphorus-based planning, what happens? You meet the phosphorus crop needs, but you typically would undersupply the crop needs for nitrogen, particularly on something that's a heavy nitrogen feeder like the corn or Bermuda grass. And it generally, as a result, because you're applying less, you're lowering your rate of application. Okay, so question. This is a simple yes or no. Does North Carolina livestock produce more phosphorus than it can utilize? So statewide, we looked at how many animals there are in the different categories: poultry, swine, beef, etc. Does their output of phosphorus exceed what we can utilize with growing crops and pasture in North Carolina? Okay, Steve says yes. Anybody else comment? Well, Steve wins. Okay. Here's the quote from North Carolina State University. I just highlighted the red to keep things moving along. Well, thank you, Catherine. North Carolina has stark agricultural nutrient imbalance by importing animal feed and concentrating the nutrients in manure. North Carolina farmers have more phosphorus than they need. There's value in it, as this says, but the problem is it's stuck at the bottom of North Carolina hog lagoons. And we talked about the sludge earlier. That's what they're referring to. And we're going to get into this in like 30 seconds, hopefully, if I can keep on moving. But I went to an interesting meeting the other week, the Irrigation Society in North Carolina, where somebody addressed this directly, this importing animal feed. He said it was about a 2-to-1 ratio of feed that's imported versus what's grown here. So it's a very large quantity. So what does this do? When you're importing all this feed, you have phosphorus more than you can utilize. You end up with 84% of the soil tests that are going through North Carolina lab that are high or very high in phosphorus. And what that means to you, why it's relevant to you and why it's relevant to your farmers is if you're in high or very high category on your soil test for phosphorus, you're not going to see any yield response if you apply additional fertilizer. So it's very relevant to knowing a lot about nutrient management. And this just further illustrates the point that if your soil phosphorus is high or very high, there's essentially no fertilizer recommendation for that because you don't have any crop yield response, essentially. I just answered that question. So there are circumstances where you're limited, where phosphorus risks have to be assessed, and you may end up limiting your application. And the tool that's used to assess the risk of phosphorus loss is PLAT, and that is embedded in the nutrient management software. And what it does is it basically evaluates your risk based on all the factors that are in play: your soils, your manure, how much, et cetera, et cetera, et cetera. Anyone use this tool, PLAT, at this point, or even heard of it? Okay, got a yes. Well, this is the output of running PLAT. You get a result that says, based on my risks, what limits me? Can I still apply based on nitrogen? Do I have to limit it to the phosphorus removal rate? Or am I prohibited from applying additional phosphorus? So that's the significance of the PLAT requirements and what the output might be from that. Here's something else to be aware of. We mentioned about all this stuff about nutrient management and where it's applied and when and so forth. Well, this is directly related to what I mentioned earlier about the buttable acres. Each type of facility, based on its permitting and based on the type of manure, has different setbacks for application. Some of them are detailed there for swine. Some of them are detailed here for poultry. So boil all of nutrient management down. It's a whole suite of practices that are involved. We mentioned all of these, at least on the superficial level. And with more time and more training, we'll get into much greater detailed depth on that. The tools that you'll come into contact with for assessing nutrient management risks and nutrient management planning are some of them are detailed here, things we mentioned already. Phosphorus loss assessment, nitrogen leaching, or nitrate leaching, I didn't mention yet, but that's built into Russell 2 as well, but it's also a necessary component for doing the nutrient management planning. Okay, so I know we got a few minutes left, and we're gonna push through this a little quicker than we could spend more time on it, but let's do it quickly as we can. So some guy rolls up to your office and said, "This is what I'm doing. I'm building 4 new broiler chicken houses. How many acres of corn nitrogen will the chicken litter supply, and how much would I need to apply to supply that nitrogen?" So here's the kind of things that you would need to ask to answer that question. How many chickens are you planning to house? Then we would go back to the tool we looked at. We'd figure out for the crop we're growing, how much nitrogen would need to be applied to grow that crop. Will it be incorporated in the soil? In this case, yes. And will you take all the manure out of the houses? In this case, no, just the cake. So to figure out how much manure we're dealing with, we refer back to a nutrient management chart that looks like this, developed by the university. It says for each 1,000 birds, we're going to produce about 4 tons of waste per year. Based on our numbers, we get 640 tons a year. How much nutrients are actually in that? We'd look at a table like this that tells us how much nutrient each type of waste may contain. And in this case, it's 57.8 pounds per ton, gives us a total of 37,000 pounds per ton, or sorry, 37,000 pounds per year. How much of that is available? This refers back to the question about, are you going to incorporate it or not? You're going to lose some to the air if you do not incorporate, so you get a little higher availability rate if you do incorporate. Not that that's necessarily what you would want to promote from a soil loss perspective, but in this case, that's the scenario. So how much acreage you're going to need, you do a little bit of arithmetic here, and you come up with 173 acres. Works out to about 4 tons per acre per year for that facility. Okay, so this is a question for you, referring back to what we've talked about so far. If the farmer meets these nitrogen requirements with the chicken litter, will he meet or exceed his crop P needs? Give me a quick response here. Exceed. Thanks, Josiah. Here's the calculation. You're going to remove about 72 pounds per acre for the crop, and your application based on how much the content is about 160 pounds. So the tools that we would use to assess how much risk that creates, we take all these consideration, and ultimately it's the plat result that gives us the risk for that application. Okay, so finally I'm back to the lagoon question. Here's the typical design cross-section of a lagoon, the different aspects of the storage: accumulated sludge, permanent liquid treatment storage, temporary liquid treatment storage, heavy rainfall factor, 25-year storm, and the freeboard. So to answer your question, if the lagoon is designed correctly and managed correctly, there is supposed to be adequate storage within the structure to store a 25-year storm and still have a minimum of 1 foot of freeboard in addition to that. And so if I understood your question, if operated correctly, should it be able to design or store large storms? The answer is yes. That doesn't mean that every one of them is managed correctly, because if it would happen to be completely full at the time we got a large storm, that could change the answer to that question. So, and you had a question as well about closing lagoons. This is a scenario for closing lagoon. I need to remove all the sludge from my hog lagoon, which is a step to closing the lagoon. How many acres of corn do I need? I'm going to run through this quickly. We could spend a lot of time on this. This is much more involved than we have time to divulge, but under his normal operating plans for his about 3,000 head feeder to finish operation, he has 21 acres of spray field available. That's the only acreage he owns, and that's not unusual for swine operations. That the land that they have and own and have access to is what that is in their spray fields for their wastewater. But when you start talking about sludge accumulation, many of them have had sludge accumulation for 25 to 30 years without having any removed, and it ends up being a significant volume. These are the numbers we're going to use in this case. Do a little bit of arithmetic, and we come up, based on nitrogen-based plan, 142 acres to apply the sludge. Remember, they only had 20 acres that they owned and operated, so they're having to look for additional acreage. But what if the case is he's getting cost share and we have to run plat, and the plat result tells us we can only apply based on the phosphorus rate? We do the math again, we come up with 740 acres. So these are the challenges that we face with getting the lagoons that are not in operation, that are full of sludge, closed. The fact is that the acreage and the cost to remove that sludge is significant, and in a lot of cases, well beyond what is feasible. So we have a real dilemma in some of these cases. We under that swine and dairy program, we have funding to approve a lot of lagoons, but because of this specific circumstance where the acreage is simply not available to the producer, we're going to have challenges getting a lot of them to actually get closed. So that's the deal on nutrient management. That's your intro. And if you have any questions, we can roll with that. Otherwise, I'll turn it back to Dalton.
All right, we are a little bit over time.
Yeah.
I think, Mark, if they have extra questions, I guess they can. You're all right with them message you on Teams or email.
Yeah, anything. My email. Yeah. It's just Mark. My email is just my name, mark.seibert, SEIBERT. That's ncagr.gov.
And we will both give presentations over to Brandy, and Brandy said she would send that out. So you guys should have a follow-up when she's well and back at it, hopefully. But if you have any questions, feel free to reach out to either one of us. If not, thank y'all for coming. Hopefully y'all learned something. I learned stuff.
Yeah, and feel free to give Brandy feedback on what we did in terms of whether it met your needs or not, so she can adjust what she's telling us that she would like us to do.
Yes, that helps a lot. A whole lot.
All right, thanks everybody.
All right, happy Thanksgiving, you all. Have a good week.